All right, so 2.7, composition of functions. So does anybody play baseball or softball or tennis? Does anybody play baseball, softball, or tennis? Yeah?
Yeah.
Yeah, what's your bat made out of?
Aluminum.
Aluminum. Really, just aluminum?
A composite.
A composite. What is a composite? Multiple things put together. All right, and so just like in that real world life scenario, like a composite bat or a composite racket, we have composite functions, which means we're going to put functions together. All right, and so that's what a composite function is. All right, so let's consider these functions first. F of x is equal to 2x minus 3, and we're going to evaluate the following. So let's evaluate f of 5. So what do we do with 5? We substitute it in. Very good. All right, so we substitute it in. So now we have 2 times 5 minus 3. And so 2 times 5 is? 10 minus 3 is? 7. Love it. All right, the next one, we have f of c. So what do? We substitute in c for x. So what are we left with? 2c minus 3. Love it. All right, the next one, we're going to substitute in 4a in for x. So we now have 2 times 4a. How many a's do I have now? 8 a's. All right, so now I have 8a minus 3. And this one, I'm going to substitute in 5x minus 1 in for x. So I'm going to show the work on this one. So now we have 2 times 5x minus 1. And then we still have minus 3. So what should we do with this 2? Distribute it. So how many x's do we have? 10. You might be called something. And then we distribute 2 with negative 1. And we get what? Negative 2. And so negative 2 and then minus 3 is how much? Negative 5. Love it. All right. My birthday boy is going to read for us composite functions. Here we go.
Sometimes in math, we would plug in a value for x.
Oh, snap. What should we do?
Substitute.
Love it.
Into a function, then use the output and answer to substitute in another function. When we substitute in output y of one function back into another function, this is called a composite function.
All right, fantastic. All right, so let's look at this first one. So we have g of x is equal to 3x plus 1, and let g of 2 equal c. And so we need to find f of c. But before we find g of c, what do we need to do? Solve for what? C. We need to figure out what c is. So we're going to substitute in what? G of 2. And so what is g of 2? When I substitute in 2 here, what do we get?
7.
We get 7. And so now I have 7, which is equal to c. So then when I find g of c, what are we actually going to substitute in? 7. And so when we substitute in 7, I now have 3 times 7 plus 1. So we'd end up with how much now? 22. Love it. All right. All right, Trace, keep going. You're doing great.
There are
How many ways? 2. Good job.
ways that we can write composite functions.
All right, the first one we're going to call f of g of x, like that. All right, some people call it fog of x. I don't personally like that term. However, that's one way. And then the other way they write it would be f of g of x, like that. I personally enjoy that way better. However, both of these are read as f of g of x. All right, they are not being multiplied. They are a composite. All right. All right. Keep going. You're doing great.
When working with composite functions, we start on the
Inside. We start on the inside.
right. If given f of g of x,
We're going to evaluate. Which one do you evaluate first?
f of g,
Okay, if we have f of g of x, which one do we evaluate first?
g of x.
G of x. And then we use that answer from g of x and what? Substitute it into f of x. All right. So I always think of Shrek when this happens. It's like an onion. All right. But you go from inside out. It has many layers. All right. So here we go. Example 2. So we have f of x is equal to this and g of x is equal to that. And we're going to evaluate. So if I find f of g of 3, what do I need to find first? G of 3. I first need to find g of 3. And so when I find g of 3, I just substitute in 3 in right there. And so what do we end up getting? 2 times 3 is 6 plus 1 is 7. So g of 3 is 7. And so from there, I need to find f of 7. All right? Because g of 3 is equal to 7, so now I need to find f of 7. So now I substitute in 7 in for x in this one. And so now I have 3 times 7 minus 5. And so 3 times 7 is 21. 21 minus 5 is 16. So f of g of 3 is 16. All right, see how we did that? We go inside out. And so on this one, that's also a movie. And so this one, what do we need to do first? Find what? F of 3. So first we need to find f of 3. And so what is f of 3? When I substitute in 3 right there, what do we end up getting? 4. And so after I find that, I now need to find g of what? 4. And so g of 4, I substitute in 4 right there. And so I end up with how much? 9. And so now g of f of 3 is equal to 9. All right. All right, let's do the next one. So now we find f of 4. All right. And so the first thing we need to do is find f of 4. And so we're going to substitute in 4 right here. So 3 times 4 is 12. 12 minus 5 is 7. And so f of 4 is 7. So now I need to find f of 7. And so again, I'm going to substitute in 7 right here. So 3 times 7 is 21 minus 5 is 16. And so I'd end up with f of 4 is 16. All right. Now we're going to find expressions / equations because we are going to put an equal sign on it. So now we're going to basically be in terms of our variables. So this first one we have f of g of x. So what do we take? We put g of x into f. Okay, we're going inside out again. And so my g of x is this 2x plus 1, and I'm going to take that and I'm going to substitute it in the variable in for that guy. All right, and so now I'd end up with 3 times, what is g of x? 2x plus 1. And then I still have minus 5 in for f. All right, and so what do we do with this 3? Distribute it. So how many x's do we have? 6 x's. All right, and so now I'd have 6x, and then what does my constant go to? So plus 3 and then minus 5, which is minus 2. All right, if you need to make multiple steps, that's fine. All right, let's do the next one. So now I have g of f of x. So what do? Put f into g. All right, and so now I'm going to take this one and substitute in the equation for that one. All right, and so now I have 2 times 3x minus 5, and then still plus 1. All right, and so what do we do with the 2? Distribute it. So now my g of f of x, how many x's do we have? 6x, and then my constants, 2 times negative 5 is how much? Negative 10 plus 1 is negative 9. All right, so I'd end up with 6x minus 9. All right. So on example 4, we're basically doing the same thing as what we've done before. So now we have 4 equations, and now we're going to evaluate k of h of 2. So what do I need to evaluate first? H of 2. All right, and so h of 2, I substitute in 2 right there, and so h of 2 is how much? 1. And so now I need to find k of 1. And so now I'm substituting in 1 right here. All right, so 1 squared is 1. 4 times 1 is 4 plus 5. So how many do I have altogether? 10. So k of 1 is 10. So k of h of 2 is equal to 10. All right. Now, I personally don't like this notation. However, you need to be aware of it. So h of m of negative 1, I'm just going to rewrite it to be like h, that's an h. H of m of negative 1. All right, I personally like it written that way. I just think you make less mistakes that way. Because when I see students do this, sometimes they think it's multiplying, and it's not multiplying. All right, it's an of. All right, and so the first thing I need to do is find m of what? Negative 1. So I first need to find m of negative 1. And so I substitute in negative 1 right there. And so we'd end up with how much? -1. How about that? And so m of -1 is -1. So now I need to find h of -1. And so now I substitute in -1 into h. So now I'd end up with how much? -5. So h of m of -1 is -5. All right. All right, cool. So now let's do the next one. So I have k of p of x, and that's notated the same as k of p of x like that. And so what are we going to do? Take my p equation and do what? Substitute it into k. Now, how many variables do I get to substitute in on this one? 2 of them this time. All right. And so let's explicitly write it out. And so now I'd have the square root of 3x plus 1. And then I do what to it? When I substitute it in right there, I'd now have it to the power of 2. And then plus 4 times the square root of 3x plus 1. And then I still have plus 5 chilling. All right. Now, when we simplify this one up, a square root squared, what happens? Cancels out. All right. It's the radicand. That's what's inside. And so now I'd have 3x plus 1 plus 4 square root 3x plus 1, and then plus 5. Now, there's one more thing that we can do. We can put our constants together, and so we can put our 1 and 5 together, and that becomes what? 6. And so now we have 3x plus 4 square root 3x plus 1, and then plus 6. All right, and that's all we can do from there. All right, pretty good?
Yep.
Cool. All right, so now let's look at this one. And so at the beginning of our pre-calc days, I told you that things are going to be written in 4 different ways. And so they're going to be graphical, they're going to be tabular or numerical, they're going to be analytical or algebraic, and they're also going to be verbal. Okay, and so this is the 4 ways that AP is going to assess you this year and next year in calculus. And so we have to be comfortable with them. All right, and so here's what we have. Now, let's do a brief overview of our piecewise function. So remember our domain things. All right, so if I need to evaluate like h of -3, which one do we use? The top one. All right, we're using the top one because -3 is less than 1. Does everybody follow me? If I were to evaluate h of 3, which one do we use? The bottom one, exactly, because 3 is greater than 1. If I were to evaluate at h of 1, which one do we use? The middle one. All right, make sense on those? All right, so let's look at the verbal one first. All right, Ethan, since it's Trace's birthday, go ahead and read k of x for this one right here. This one right here.
K of x is a quadratic function with a horizontal translation of 2, followed by a vertical translation of -3.
All right, cool. So it's a what kind of function?
Quadratic.
Quadratic. What makes it a quadratic? A degree of 2. All right, so we're going to build k of x because it doesn't explicitly give it to me. This is it doing it verbally. And so this quadratic function, which has a degree of 2, has a horizontal translation of 2. And so what's inside my function? Is it x plus 2?
Wait.
It's x minus 2 because it's shifted which way? To the right 2. All right. Now, if it said horizontal translation of -2, then it would be what? X plus 2. All right. And then it's followed by a vertical translation of -3. So what goes on the outside? -3. All right. Remember, the x's do the opposite and the y's do what you think it does. All right. That's why they're the x's. All right. So there's our verbal translation of that one. All right, so now let's look at example 5. Ethan's going to keep reading. He's doing great.
The graph of the function f of x is given above, along with a table of selected values for the function g of x. An equation of the piecewise function h of x and a verbal description of the function k of x. Use this information to evaluate the following, if possible.
All right, fantastic. So the first one we're going to do is f of g of 3. So what do we need to find first? G of 3. We need to find g of 3. And so let's look for g. This one's f. This one's g. So do I have g of 3? Here's my x values. Do I have g of 3? No. These are my output values. So like g of 5 is -2. Do I have anything at 3? No. So can I do it? No. This one's not defined. All right, so I can't actually do this problem because it's not defined. All right. All right, let's do the next one. So we have h of f of 8. All right, so we have h of f of 8. So what do we need to find first? F of 8. And so now I need to look at my little f graph. And so here's f. So what is f of 8? Negative 1, exactly. All right, and so now I have f of 8 is equal to negative 1. So now I need to find h of negative 1. Now, h is my piecewise function. So which one do I use? So if I look at my domain restraints, which one do I use? The top, the middle, or the bottom? The top one, because negative 1 is less than 1. And so now I'm going to substitute in negative 1 right there. And so now I have the absolute value of negative 7 plus 3 times negative 1. So what is 3 times negative 1? Negative 3. Negative 3 plus 7 is negative 10. However, it has absolute value brackets around it. So what do we get? 10. And so that composite function is 10. All right, I think of these as like little puzzles, which is kind of fun. All right, let's look at the next one. So I have g of k of 0. And so what do we need to find first? K of 0. All right, so the first thing I need to do is find k of 0. Now, we went ahead and already did this equation to this verbalizing. I would suggest doing that. All right, does everybody follow me on this? Because now we're going to use it. So we're going to substitute in what? 0. So 0 minus 2 is? Negative 2 quantity squared is 4. 4 minus 3 is 1. All right, so k of 1 or 0 is equal to 1. So now I need to do what? Find g of 1. And so now I need to look at my table. So do I have g of 1? No, I don't. So what do we got?
Undefined.
Undefined or not defined. Do you need me? Here we go. F of 2. So the first thing, or f of 2. So the first thing we need to do is find f of what? 2. All right. And so we look at our little table, or our little graph, I mean. And so what is f of 2? 1. That's where it's dotted and it's right there. All right. And so now we need to find f of 1. And so what is f of 1? 4. It's right there. All right. And so f of 2 is 4. All right, let's do the next one. So now we need to find g of h of 1. And so the first thing we need to do is find h of 1. So now we need to find h of 1. So I need to look at my piecewise. So what part do I look at? The middle part. And so what is h of 1? Negative 4. And so now we need to find g of negative 4. And so now I look at g of negative 4. Is it there? Yeah, what is it? Pi. All right, let's do another one. And so now this one is a doozy. All right, so now I have g of f of h of k of 3. So what do we need to start with? K of 3. All right, so now we need to find k of 3. And so we already found our equation for that. So we substitute in 3 into this quadratic. And so now I'd have 3 minus 2, which is 1 squared, minus 3. Negative 2. So now I have negative 2. So now what do I need to find? H of negative 2. And so then when I find h of negative 2, which part am I looking at? The top part. So I'm going to substitute in negative 2 right here. And so 3 times negative 2 is? Negative 6. So negative 6 minus 7 is? Negative 13. However, what do I want to do to it? Absolute value it. And so I end up with 13. So then once I have 13, what do I need to find? F of 13. And so now I need to go to my f function. Do I have f of 13? Nope, don't have it. What do I do, Eduardo? Not defined. All right. So this is not defined or undefined. All right.